Hi, in this video I'm going to take you through a refresher on how to do present value calculations. So in the Fin module we're often thinking about the time value of money. So which lottery win would you prefer? $20,000 now or $20,000 in 3 years' time? I don't know about you, but I prefer the money now. So $1 today is worth more than $1 in the future, and that means that future values need to be discounted. Where do we see present value calculations in the Fin module? In Unit 3, when we're discounting revenue, where there is a significant financing component, so delayed settlement. In Units 7 and 11, where we're talking about property, plant and equipment, and there's a restoration for future costs, or often called make good provisions. So we need to recognise a restoration provision and we capitalise it into the assets value. In Unit 9, with financial instruments, the liability component for compound financial instruments, as well as impairment of financial assets in certain situations. In Unit 11, when we're discounting the expected long service leave payments to calculate the liability in this year's financial statements. Unit 12, lots of PV calcs for lease liabilities for the lessee and the lease receivable for the lessor. And finally, in Unit 15, where there's deferred consideration in a business combination. Now, you can be using a calculator to do these present value calculations, or we can use the present value tables that you find at the back of your candidate study guide. In the Fin module, the discount rate to be applied will be given to you. You won't need to go through a calculation to arrive at the discount rate. So for starters, it helps to think about the nature of the cash flow that we need to discount. So if it's an individual payment, then what we're going to look at is using the present value tables of $1 after X periods. So in this part of the video, I'm going to be taking you through how to use those present value tables. Alternatively, if you've got a series of payments of the same dollar value, then you can be applying the annuity factors where there's $1 per period for a series of periods. So let's have a look at these tables. So I've got an extract for you here. So here's the present value of $1. So this is for individual payments. Now here's an extract from the annuity tables for a series of payments of the same amounts. And you can see that for period 1, the factors are the same in both tables. And that's because it's just one period. But you can see, say in the annuity tables, that the nature of the factors change, and you can see they're greater than 1 because we're talking about a series of payments of the same amounts. So when you use these factors with these present value tables, to discount the dollar values, you need to multiply by these factors. Now, alternatively, some people prefer to use the compound amount tables. It's your choice as to which table makes more sense to you. And these compound tables are just the inverse of what we saw with those PV tables I've just shown you. So for the individual payments, we're looking at these factors. So again, it's because it's looking at it from a future value perspective. So you can see those factors there. And if we're using the compound tables for a series of payments of the same amounts, then we're using this table number 3. And you can see in all situations, these factors are greater than 1 because in this instance, we divide by the compound amount factor to arrive at the present value calculation. Okay, I'll now take you through a calculation using a relatively straightforward example. I'm going to keep using those present value tables as I think they're a little bit easier to understand. But remember, it's your choice of how you do your discounting. But in an exam, just make sure you show your workings so the examiner understands what you're doing. Let's say that today is 1 July 20X0 and a company has contracted to make 4 payments of $100,000 and they're to be made in arrears each 30 June. The discount rate that I'm using is 6%. So here's my payments. You'll see year 0, 1 July X 0. I've got nothing to pay, and those deferred payments of $100,000. So I'm going to use my present value of $1. So the individual payments. So remember, I multiply by these factors, and you can see I multiply them across, and my discounted amount of those 4 lots of $100,000 is a discounted amount of $346,510. Alternatively, I can apply the compound factors. Now you can see there, if you wanted to use your calculator, you'd be taking 100,000 divided by 1.06 squared. If you want to use a calculator, go for it. Now I'm going to look and say, okay, what if I applied those compound amount factors instead? So I'll rework it in this pink part of the table here. Remember, with the compound factors, we divide. So you can see I'm dividing by those factors from that table, and my answer there is 346,511. So a very slight difference between the two present value amounts, and our markers look out for rounding differences. So relatively straightforward there. Work out which one you use. I think present value factors are a little bit easier to understand. We just multiply them through. I'll change that scenario a little now and say, what if there was also a $100,000 payment to be made on 1 July 20X0? Okay, in this situation, what I do in my table is my present value factor is actually 1. We don't need to discount it because that payment is being made today. So therefore, my total present value is now 446,510. So that's what we need to do. We apply the factors to the other amounts, and an upfront payment just has a PV factor of 1. So a different way to approach my calculations is if I use the annuity factors. So remember, there are facts 4 payments of 100,000 to be made in arrears. So I can see then that 6% for 4 periods, my factor is 3.4651. I've got the payment, that stream of money that I'm paying, 100,000, I multiply by 3.4651, and there's my present value. So it's quite easy when you've got the same amount being paid all the time to discount the amount if you use the annuity factors. It's a little quicker than discounting one by one. So again, let's use the annuity factor for my what if. What if I also made that upfront payment on 1 July 20X0? Again, I still use that factor, and I've got a series discounted to 346,510 plus that upfront payment. Because it's made in year 0, there's no discounting. So there's my answer again, 446,510. The same as what I calculated earlier. Instead, what if I made an additional payment at the end? So if I had to pay 200,000 at 30 June X5, how would I go about doing this? So again, there's my present value tables. 6% after 5 years, the factor is 0.7473. So I can use my annuity factors again. There's my 346,510. Plus I've got a one-off payment, so I can't use my annuity factors for that because I've got my 4 lots of 100,000 that I've discounted in that first row, but there's one-off amount I need to multiply by 0.7473. So the total discounted amount then is 495,970. Now I could go through line by line as I did in the earlier slide and discount each of the payments of 100,000 using those factors and then do that final amount for the 200,000. It's your choice about using annuity factors or the one-off payment factors. I hope that helps to clear up present value calculations.